Alright, so this question is prime number of set bits in binary representation. So you're given the left and right. So you want to count as the number of set bits between the interval, right? So let's look at this. So for the left and right, it's going to be 6 to 10. So look at this. So 6 is representing 110, which is what? Two value for 1, right? So it's going to be 2 is a prime. So this will be 3 value of 1. So 3 is also prime. This will be 1 value of 1, that one set bit, right? So 1 is not a prime, so you don't count this one. And this will be 2. 2 is also a prime, right? 2. And then another one, last one, 10, 10, 10 is also 2. So it's the number for prime set bit is what? 4, right? So if you actually look at this, the constraint, so we want to know like it's between 1 to 10 to the power 6, right? So 10 to the power 6 is what? Let me draw a little bit bigger on this one. 10 to the power 6 is equal to 60, right? So what is this representing in 2 to the power of, so it's going to be 2 to the x, right? So it's going to be using the pretty much algebra, right? So you take log for this, so it's going to be 6 log 10 equal to x log 2, and then we know what log 10 is what? 1, so it's going to be x is going to be equal to 6 divided by log 2. So log 2 is 0.3. So if you do this, math, you guys end up 19.9 something like this. So it's equal to 20. So x equal to 20, right? So the maximum bit you can get is 20. So it's gonna be 1 all the way to what? The last one, right? So from here to here, if all the bits set equal to 1 is 20. So we already know the prime bit is what? 2, 3, 5, 7, 11, 13, 17, and 19 between 1 to 20. So so what we can do is this. We can create a hash set integer, right? I'm going to call prime equal to new hash set, and then array s list, and then call it, move a little bit left. So it's going to be 2, 3, 5, 7, 11, 13, 17, and 19. So this is the range between 1 to 20, right? We already know 4 is not a prime, 6 is not, 8, 9, 10, 12, 14, 15, 16, 18, 20 is not prime, right? So just between the just between the left and right interval, right? I want to check does the current value is a prime, so I'm going to create a helper function is prime, send the I value into it. If a prime, we add 1. If not, we add 0, and we return result, right? So public boolean is prime in num. So how do we determine this is a prime value? I will just look at the bit, right? Return prime that contains bits. So we check for 1, right? So for I equal to num, right? I greater than 0, and every single time we shift right by 1, and then we just basically keep adding the im1. The im1 is actually equal to 1, then we just add 1. If that is equal to 0, then it's just plus equal to 0. It doesn't matter. So this will be entire solution. This should be okay. Yeah, this is the optimal solution. So let's look at the time and space. This is a space constant time between left to right. So it's going to be all of them. And this will be between the num. Num is the value between what? Is it 10 to the power 6, right? Sorry, 10 to the power of 4, I believe. I mean, I mean, just determine the length of the num. So this is all of n multiply the is prime. Is prime is going to be between the num. So it's like all of capital N, all of little n. So the worst case is going to be time. Worst case is going to be all of capital N and little n. For the time, space is constant. Pretty much it, right? You can use array this and then traverse to check, do you have this value inside it? If not, return true or false, something like this. Alright, so this will be the entire solution. So it's a little bit tricky because you want to calculate the prime number, but whatever. So if you have questions, leave a comment. See you later. Bye.